Hi everybody. Today's problem is to find the value of an expression containing three variables using the given set of equations. This is a difficult problem that I saw when I surfed Facebook but still have not seen anyone with the correct solution. Now let us analyze the problem to find the correct answer. First, we see that the expression a to the power of 9 plus b to the 9 plus c to the 9 is a symmetric expression, that is, if we change the order of a, b and c, the result of the expression does not change. Looking at the equations, we can see that these three equations have similar forms and are all polynomial functions of degree 3. However, if we solve the equation to find a, b, c, we will get an irrational solution or even complex solutions. I suddenly remembered the property. We will consider the polynomial equation of degree 3, x to the 3 plus x plus 1 equals 0. We see that a satisfies the equation, so it is a solution of the equation. Similarly, b and c also satisfy the equation, so b and c are also solutions of the equation. Furthermore, a is different from b and different from c, so we have a, b, and c as three different solutions of the equation. Also, the equation has degree 3, so there will be at most 3 solutions. From there, we have x minus a times x minus b times x minus c equals 0. We will expand the polynomial. The first is x minus a times x minus b. We have x times x as x squared, followed by subtracting x, subtracting bx, then adding ab. Grouping minus x and minus bx, continue using the second degree polynomial to get times x minus c. We have x squared times x is x to the third power, then minus the sum of a and b times x squared, plus abx, minus c x squared, plus a plus b times c times x, finally minus abc. We will simplify by adding exponents of the same degree. First x squared, we have minus the sum of a, b and c times x squared. The second is x, we get the sum of a b, bc, and ca multiplied by x. After performing the polynomial expansion, the above equation becomes x to the third power minus the sum of a, b and c times x plus the sum of a b, bc, and ca times x minus a bc is 0. Compared to the original equation, we have two equivalent equations, so the coefficients are identical. We have minus the sum of a, b plus c equals 0. ab plus bc plus ca equals 1. Minus abc equals 1 or abc equals minus 1. If you know the Vieta-S formula theorem, you can determine these equations quickly. Using the three equations above, we can find the value of any symmetric expression of a, b and c. Going back to the problem, we will try to represent the expression a to the 9 plus b to the 9 plus c to the 9 in terms of the sum of a, b and c, the sum of ab, bc, and ca and abc. We see that the given equation has degree 3, so we transform the expression into the sum of powers of 3. Add to both sides of three equations minus a minus 1, minus b minus 1, minus c minus 1, respectively. We get the expression of a to the third and c to the third power in term of a, b and c, respectively. Substituting it into the expression, we get minus a minus 1 to the power of 3 plus minus b minus 1 to the power of 3 plus minus c minus 1 to the power of 3. The common factor here is 1. We have xy to the power of n equals x to the n times y to the n, so minus 1 times the plus 1 to the power of 3 is equal to minus 1 to the power of 3 times a plus 1 to the power of 3. Do the same for the second and third terms. Because minus 1 cubed equals minus 1, we take it out of brackets. Applying the third degree equality constant, we get that a plus 1 cubed is equal to a cubed plus 3 squared plus 3a plus 1. Again, a cubed equals minus a minus 1 plus 3a squared plus 3a plus 1. 1 minus 1 equals 0, 3a minus a equals 2a, reducing them we get 3a squared plus 2a. Do the same for the second and third terms. Grouping the terms with the same degree gives us minus 1 times the sum of 3a squared plus 3b squared plus 3c squared with 2a plus 2b plus 2c. Then, take the factors of 3 and 2 out of 2 terms, respectively. We have a plus b plus c equals 0. Put it into the expression, we get 2 times the sum of a, b and c is eliminated. To use the equality constant, the sum of 3 numbers, the sum of a, b and c to the 2 equals a squared plus b squared plus c squared plus the sum of 2ab, 2bc, and 2ca. In the expression, we add and subtract 2ab plus 2bc plus 2ca. We get an expression of the form a, b and c to the power of 2 minus 2ab minus 2bc minus 2ca. Alternately, replacing the sum of a, b and c equals 0 and the sum of a, b, bc, and ca equals 1, we get the final result is 6. Thus, we have found the value of a to the power of 9 plus b to the power of 9 plus c to the power of 9 equals 6. This is a great math problem, isn't it? If you have a better solution, leave a comment below to share. Like, share and subscribe to learn more with Road to Infinity. Thank you so much. Goodbye.